What's up everyone, welcome to the 27th tutorial in our Python Language Basics course. This will actually be the final lesson, and here we're going to go over some examples of static members in action. So when I say members, I mean variables or functions that belong to a class. So we're going to start by creating a static variable, then we'll create a static function, and finally we'll learn how to access and use these static members effectively, and of course compare them to what we've been doing so far. So let's head on over to the code now. Alright, so this is where we left off last time, section 26, inheritance, and then we created our subclass called player character and demonstrated the difference in access between subclasses and superclasses. Now, even though we have two distinct classes, one still being a subclass of the other, we are only using what are called instance members. Okay, so everything so far that we've covered, all of these variables that we've created, so let's say like name, exposition, health, number of lives, max health, etc., these all belong to an instance of a class. Okay, that means in order to access them, let's say if we wanted to access max health, or we wanted to call upon this function, or we wanted the exposition, etc., we have to first create an instance of our player character or an instance of the game character. So that means that each instance of player character or game character could actually have a completely different value for those. It could have a different exposition, each one could have a different max health, each one could have different health, etc. Okay? So essentially that value belongs to a specific instance of the class. Same with the methods as well. Those methods can only be called on instances of classes, so they're considered instance methods. Well, that's where static variables and functions, or there's static fields and static methods, come into play. Is that they actually belong to a whole class, and so are kind of consistent across all of the instances of that class. Now, as with everything in Python, static members are a little bit more flexible than in other languages, but generally speaking, they should follow the same convention. So let's take a look at an example. If we scroll up to game character, what I'm going to do is I'm just going to create a variable called speed. So this will be a static variable and belongs to the game character class rather than an instance of game character. So I'm going to create my variable up here. I'm going to call it speed, and I'm just going to set it equal to 1.0. So at some point in time, maybe the game is progressing forwards, a player reaches a certain point, and the speed increases. That might make things a little bit more difficult, especially in like a runner type game. Then things are going to come at you faster. You're going to be moving faster. It's going to be more difficult to avoid things. Okay, so we have our speed of 1.0 here. Now this, as it stands right now, is actually a static variable. Because we're not calling upon self.name equals name, it's not self.speed is equal to speed or whatever. It belongs to the class because it's not self.speed. Okay? So this actually makes it static. And that's why we set our variables down here, because if we set them up here, technically they would be static variables. Okay, so what we're going to do then is create also a static function to demonstrate how to change this. Now, realistically, we can just access this and change it, but it's better practice to create a static method or function to do so. So we can create a function, and we're going to call this change speed. Okay, and we'll have a toSpeed, and then we're going to say speed is equal to toSpeed. Okay, so what is different about this function than the others? Well, the big difference is that it's missing the self keyword. Okay, so the self, again, just like this, means that it belongs to an instance of game character. Because we're creating a static method, we're not going to be using self anymore because it doesn't belong to an instance of game character. It belongs to game character as a class. Okay, so this is an example of a static method. So they look really similar. The only difference is that it doesn't have the self keyword. And in this case, static methods are going to be used to change static variables. Okay, so let's take a look at an example of that in action. We'll go ahead and run that cell. And I don't think we need the others because we're not going to be dealing with player characters or anything like that. So we'll start by creating a new cell down here. Okay, I'll just zoom in a bit more for you guys. All right, so let's create a couple of instances of a game character. We'll create a GC1, it's going to be a game character. Okay, let's say, I don't know, this is a wolf again or something. Starts at position 0, 100 hit points. We'll create a GC2. This one's maybe like a lion or something. Starts at 2 and has 150 health. Okay, so that's good. We've got a couple. We know that we can access their instance variables and instance functions just like before. We could do gc1.move, for example, or check is dead. Same with gc2. No need to go over that again. But what about the speed? Okay, so what we could do is we could print the speed of GC1 or 2. So, you know, let's demonstrate that first, GC1 and GC2. Okay, like so. Let's go ahead and run it. Okay, and we're getting an error here. Game character is not defined. Oh, that's because I spelled it wrong. There we go. Okay. And that's not actually what I wanted to do. What I really wanted to do is print out the speed. Okay, it's getting ahead of myself a little bit there. Okay, there we go. So we get 1.0. That makes sense because in our game character class, we did assign the speed value of 1.0. But that's not really any different from using an instance variable, right? The main benefit is that I can print my game character dot speed, okay? And I don't need to create an instance of it. Okay, so I can totally get rid of those and just access the game character speed. Now this is very, very useful for when we don't want instances to access the values, okay? Because again, for everything that we've done up until this point, we've been accessing the values attached to an instance of that class, okay? That also means that those values can change from instance to instance, and that's not necessarily what we want. You'll very often see static members or static variables attached to classes when we need there to be constants. So constants are going to be the same across all, for in this example, game characters. So that makes sense. If our game is running at constant speed, we want all of our characters, whether they're non-player characters or player characters, to maintain a certain speed multiplier. Okay, now another cool thing I can do is I can say game character.speed is equal to 2.0. Okay, and then if I go to print these out, no longer need that. It's going to do that. Then you can see that they're both 2.0 now. So it's actually changed them both, even though I have only changed one thing here. And that's because I'm changing the speed across all game characters. Now, one of the reasons I said earlier that it's not strictly static is because I can do this. I can say gc_2.speed is equal to 10 or something like that. Okay, and that's actually valid. You can see that GC2 speed is 10, even though GC1 speed is still only 2. So in a lot of other programming languages, they won't let you do that necessarily. But again, Python's weirdly flexible, so that's totally allowed. All right, I'm actually just going to comment that out because I don't want that to be the case here. Now, the same thing again goes for methods. So realistically, we wouldn't change the speed by doing this. What we should be doing is saying game character dot change speed, okay, and then changing the value to 2.0 or something. Okay, I'm just going to comment that out. Okay, and then we get 2.0 for each one. If I change it to something different, 3.0, and we should see again, this is actually giving us the value still of 2. I think we made some mistake up there. Let's go check it out. Oh, okay, yeah, so the problem is that we're just changing a generic speed, which should be the game character speed to speed. Okay, so we'll go ahead and run that. Okay, and then we can go ahead and rerun this cell. Okay, there we go. Good stuff. So now this function should be working properly. We can change it to 4. Yeah, there we go. Good stuff there. So although we can, as you saw there, use static methods to change instance variables, it's not very good practice to do so. And a lot of languages won't actually let you do that at all in the first place. From a static method, you can only access static variables. So yeah. But that's just Python, you know, doing Python things, being flexible and all that. So that's pretty much all we wanted to cover. Basically, we use static variables when we don't want to attach a value to an instance. So we want the value to remain the same across all instances. and perhaps we don't want to have to create an instance of a class to be able to access that value. That means we often save this for constants, or if we just need to quickly grab a value from another class without having to create an instance of it. We generally use static methods to change static variables. We can modify instance variables, but it's not great practice to do so. The difference between a static method and a regular method and instance method is just the fact that we don't add this self keyword. Okay, and then static variables are created like this rather than by using the initializer. So that is it for now, and actually that is it for the entire course. This was our last lesson. As per usual, I'd recommend that if you're not 100% sure about static variables, what we can and can't do with them, you should give this a practice. When we come back, the final section will just be kind of a summary of the whole course and where we can go from here. Okay, so stay tuned for that. Thanks for watching. We'll see you guys in the next one.